Hello everyone. So welcome once again, and we are going to discuss data frame attributes in this video. So what is attribute? Attributes are properties. You know that data frame is an object, so it will have some properties. We can see those properties using different attributes provided by pandas. So data frame is having different attributes. Here we are going to discuss 14 attributes of data frame. So let's get started with transpose, that is T. What we will do, we will get the attribute value of data frame by dot operator. Since these are attributes not functions, so we will put dot operator, then we will give T. So data frame dot T. We will not use small brackets since this is not function, it is attribute. So let's get started with first attribute, that is transpose. So here what we are going to do, we have created one sample data frame. On this data frame we will execute our different attributes and see the properties of this data frame. As you can see, I have imported pandas and I am creating a dictionary. This dictionary is having roll number, name and percentage for three different students. And after that I am creating one data frame using this dictionary D, and I am providing index parameter in this data frame so that the default indexes, that is 0, 1, 2 will be changed to student 1, 2 and 3 respectively. After that I am printing the df. So let us execute this code and you will find the output. It is importing pandas. Now you have find the output. It is giving me a data frame that is with roll number, name and percentage, and indexes are student 1, 2 and 3 respectively, and I am having 3 rows of data in this data frame. So we will see each and every attribute one by one. We have 14 attributes to see. So let us start with our first attribute, that is T, transpose indexes and columns. What it will do, it will transpose, that means it will make your index as columns and columns as index. So your whole data frame will be transposed. We will use T to transpose our data frame. So what we will do, we have data frame df that we have just created, and what we will do, we will use dot operator, then we will give T. So it will transpose my data frame. So as you can see, student 1, 2 and 3 was our indexes. Now it has become columns and all the columns has become my indexes. So my data frame is transposed now. If I print the data frame, previous data frame, and then I print this, you can see the difference. See the above data frame, there are two data frames. So this was my previous data frame and now this is the transposed data frame. One thing that you should remember, that this will not change your data frame. It will print the output on the screen. If you want to change your data frame or do the transpose, you will do df is equal to df.t. So this will make your data frame transpose and will store the value in df. So for each attribute that we are going to learn, none of the attribute will change the data frame. It will print the output on the screen only. It will not change the data frame. If you want to change the data frame, you can give the data frame equal to then data frame dot your property or attributes. So now let us move to some other example. Second attribute, that is axis. So what axis will do? Axis will return a list representing the axis of data frame. What are axes of data frame? Axes of data frames are indexes and columns of that data frame. So how we will use this? Data frame dot then my properties or attribute name. So df dot axis. So after running this, you can see a list has been returned which is having index as student 1, 2 and 3 and columns as, so it is a list of indexes and columns. Fine. Let us move to our third attribute, that is columns. In case if you don't want indexes and just want the column list, number of columns, how many columns are there in your data frame, how it can be accessed? df dot columns. So you can see df dot columns is returning only columns, list of columns. In same way, if you don't want columns, you want just indexes of data frame, you can use index. So this is index attribute. So you will do df.index, so it will return the indexes of your data frame. Next attribute is dtypes. You can see in case of series we use dtype. Now we are using dtypes. S is there. Why? Because each and every column of data frame will have some data type. A single column will have single data type. That you must remember, that a single column will have single data type. So we can see those data types using data frame dot dtypes. So let us execute this. So when I will do df dot dtypes, it will return me the column data types. I had 3 columns, so it is returning 3 column values. Each column is having some data type. First column is having int64, second column is having object data type, third column is having int64 data type. And the d type, that is the whole data frame type, is object. Since data frames are objects in Python, so it is returning the data type of my data frame as object. Now let us move to a sixth attribute, that is empty. So in case if you want to see if your data frame is empty or not, you can use this attribute. It will return true if your data frame is empty, otherwise it will return false. As you can see, when I run this, so while doing df.empty, it is returning false since my data frame is having some values. Let us create another data frame df1 which is having nothing, that is empty data frame, and check this df1 what it returns. It is returning true. That means it returns true if your data frame is empty. So in case in your program, if you want to check whether your data frame contains value or not, or if you want to check if it is empty or not, so you can check it with the empty attribute. Fine, let us move to our seventh attribute, that is at. Sometime if you want to access a particular value from your data frame, so you can use at operator. It will access a single value of your data frame. You can consider a data frame as table, and if you want a value for a particular cell, you can use at attribute. So we can do df.add, then I will provide my index then columns. There is syntax to use add. You will provide first index then columns. So the same thing I am doing here. So you will provide index then columns. Let us print our data frame, what our data frame was, and we will print this as well and see what it is giving. I am giving student 1 and roll number. So at student 1 and roll number, the value is 1. So it is returning 1. If I want to check student 1 and name, I can give name here and execute it. You can see it is giving Adrija because it is having index student 1 and column name. You can change your column also. You can give this student 2. So in this case it is returning Besali. So now you will understand that how this at works. Sometimes if you don't want to use your column name and index name, then you can give the position value of it. The first is 0, second is 1 and third is 2. Likewise your indexes will also be 0 from start from 0, 1 and 2, and it will go on till the number of rows minus 1. So you can give your index positions and column positions when you use iat. So our eighth attribute is iat. To use positions of indexes and columns, we will use iat. So this is our eighth attribute, that is iat. It will also give you the single value, but you have to use your positions of indexes and columns. So you can see we will print our data frame, and we will see what is there at position number 2 and 1 and 2. One is again first index, then column name. So this is index value, this is column position value. So one is student 2, it will start from 0. So one is student 2, and in case of position of columns, 2 is, this is 0, this is 1, this is 2. So 2 and 1, this is 1 and 2. So it is coming 85. So my output is 85. Now you can see clearly my output is 85. Why? Because I am giving position of index as 1 and position of column as 2. You can change this according to your need. If I change my column value, my index is 1, so this is 1. Index is 1 means it will start from 0, so index 1 will be student 2, and 0th position of column will be roll number, so it is giving 2. Fine. Now let us move to our ninth attribute. So in case if you want to find slice of data frame, you can use our next attribute, that is LOC. So how LOC will be used? In LOC, we will provide our start index, end index of data frame, then start location, start column, and end column. Again, there is two things, LOC and iloc. In LOC, we will provide index name and column name, and in iloc, we will provide our column positions and index positions, that will start from 0 up to number of columns minus 1, and in case of indexes also start from 0 and number of indexes, number of rows minus 1. So we will see first here LOC. Let us start with our code. So this is my code. I am using df.loc. Again here I am passing starting index position and ending index position. Here I am passing start column position, then up to end. Colon means up to end. So let us see this. We will print our data frame first. What is data frame? Then we will print our values, what it is printing. Now execute it. You can see my data frame is this and my values are this. So let us see what is happening. So it is starting from student 1 up to student 2. You can see this red note here. This says that both the index elements will be included. Both the end values will be included if I use LOC. If I use column names, then both student 1 and student 2 will be included. It will not work like list slicing or string slicing, where we were providing index that positions of indexes of list or strings where the value comes one less than the index position. Here we are providing the names, so both the sides will be included. Student 1 and student 2, both the rows will be included. So we are providing student 1 up to student 2. So both the rows and all columns starting from roll number up to end. So starting from roll number up to end. So these first two rows will be printed. You can see the output. Now let us make some changes. I want only student 1 row and I want only percentage column. If I run it, you can see it is giving 80. starting my student row only, student index only, and percentage. So it is giving 80. Fine. If I want starting from starting up to percentage, if I provide colon, then it will start from first column and up to percentage. So in case you can see it is providing three things: rows, roll number, name, and percentage of student 1. So it is providing me S series object. If I provide from student 1 up to end, then let us see what it provides. So it is providing me the full data frame. If I give it as student 2, so start from student 2 up to end, and then start from name up to percentage. So in this case, what it should provide, starting from student 1 up to end, and name and percentage. So it will provide Vaisali, Arijit, 85, 89. It should provide that. Let us see. You can see this is providing this. So this is LOC. So in case of LOC, both the first and the last, both the your index elements will be, and column elements will be, column name and index name will be included in your output. Now let us see iloc. In case of iloc, we will provide start index position and index position of index value, and start index position and index position of columns. So in case you can see we are providing indexes. I denote here that we should provide indexes as indexes. In this case, if I am providing, let us print our data frame first. So you can see it is providing, we are giving 0 up to end. So it is starting from 0 up to end. Fine. And in case of column, from starting up to 2, so it will print up to 1. This is 0, this is 1, this is 2. So it will print starting from 0 up to 1. In case of iloc, it will not include both the end. It will include and minus 1, up to and minus 1. Also you can use negative positions here, negative indexes also, as we used in case of our strings and list. So if I change it, let us make it 0 to 2 and 1 to 2. So you can find what will be the output. In case we are starting from 0 up to 2, so it will take 2 rows. And in case of columns, I am starting from 1 up to 2, so it will take only name. So it should print Adrija and Vaisali name column only. You can see this is printing two things only. So this is our iloc. You can provide positions in form of numbers. In case of iloc, you can provide as column name and index names. Clear? Now let us move forward. So our 11th attribute is ndim. So it will return our dimension. So you can see, since our data frame is of table format, so it is having two dimensions, rows and columns. See here, there are rows and there are columns. This is two-dimensional data structure. Fine. And in case of series, it is a single dimensional data structure. So ndim will provide two dimensions because it is a data frame. Every time it will provide two only. Let us move to our 12th attribute, that is shape. So what was our shape? There was three rows and three columns. So it will provide 3 comma 3, a tuple which contains 3 comma 3 value. You can see if I print df, so it is having 3 rows and 3 columns. 3 rows student 1, 2 and 3, and 3 columns roll number, name and percentage. If I add one more row, then it will provide 4 rows and 3 columns. It will provide rows plus columns. Rows comma columns, number of rows comma number of columns. So let us move up to our next attribute, that is size. So size will provide the number of elements in the data frame structure, data frame data structure or data frame object. In our case there were 3 rows and 3 columns, that means there were 9 elements. So it should provide 9. You can see df.size is providing 9. So 14th and last attribute is values. So if you want your data frame to be converted into numpy array, so what you can do, you can use values. So it will return your whole data frame as numpy array. So this was our all the attributes, 14 attributes. This was our all 14 attributes. Practice it. If you are having some doubt, then you can ask me in comments. Thank you.